The next question he is asking about the configuration of aluminum and give me 4 different possible aluminum configurations. I know that aluminum has 13 electrons. So 13 electrons, this means that it is aluminum 1s2, 2s2, 2p6. So I have 2p6. I'm still having 13 electrons, so there is a lot. But now I finished 10 of them, so I have to be a little bit slow. And then I have 3s2 and then 3p1. This is the configuration that I need to find. Which of the following will be the correct configuration? So he has given me 4 options. Let's see the first option. This looks good because I can see the numbers. This is the 1s2, this is the 2s2, and this is 2p6 electrons, then 3s2 and 3p1. It looks very good to me. Let's see the other option. This is the first option. This is the second option. For some reason, I don't like this option. Let me see why. So I will say this is 1s2, 2s2, 2p6. We are going good. And then there is should be 3s2, but there is no 2. There is 1. We have agreed that you have to fill every subshell before going to the next shell. Don't go and put electrons in the 3p before finishing this one. It should be 2 electrons here, so this one is the second option is wrong. Let's see the third option. That's also wrong because this is 1s2. Where is 1s2? This is wrong from the beginning. Don't go to the 2s, and 2s also is not good. Don't put electrons here unless you finish. So everyone finish 1s2, then go to 2s2, and then 2p6, like that, one by one. Don't go to another subshell unless the first subshell before it is filled. So this is also wrong, the third option. This one is the fourth option, and the fourth option is also wrong because this is 1s2 okay, 2s2 is okay, 2p6 is not okay. This one should be done. This one should be done first. So what is 3s? You cannot put electrons up here, and since this is totally wrong, fourth option. So only the first option was right. That's 1s2. You want me to draw it the correct one again? First, I put 1s2. This is put reversal, but no problem. It's 1s2, then 2s2, then 2p6, then 3s2, then 3p1. This is the correct one. So remember the rules together. In order to make the configuration, aluminum has 13 electrons. Fill the orbitals as arranged. So first one is 2s, 2p, 3s, 3p, 4s, 3d, 4p. Hund's rule says fill orbital simply before pairing. So if you have 2p here, put here, then here before you start pairing. And notation: one is going up, spin up, one is going down, spin two. This is paired electrons. Every one of them spin in different direction to decrease the repulsion. There will be no repulsion, or minimize the repulsion, decrease it. Question 31 is talking about the shorthand electronic configuration. What is the shorthand? Instead of writing the configuration every time the full configuration, I can go to the previous noble gas in the periodic table and do its configuration in a summary. So let's see, what is the previous noble gas? This is just to a shorthand to decrease the time of writing. Instead of writing 1s2, 2s2 every time, just summarize. Let's see here in the periodic table where is iron, and let's see what is the element before it, the noble gas before it. So let's see, this is iron Fe here, so I can see it here, Fe, and then what is the noble gas? Don't see the noble gas before it, the noble gas before it, not after it. So this is Fe. I will go back. This is going back until I meet the first noble gas. About if you see this noble gas, if we are talking about aluminum, so the noble gas before it is neon. We are talking about Sp, antimony, the noble gas is krypton, like that. So go to the left until you first meet the noble gas. So iron, I will use the Ar. What is the meaning of shorthand? I will write the Ar. This means that, and then continue after it. So I will say this is the configuration of argon, and then continue after argon. I don't want to start from the beginning from 1s2. This is my element. I have to pick from the noble gases only. From the noble gases, the last group 18. So if Fe, I will choose argon. If aluminum, I'll choose neon. Choose the noble gas. Choose from the last group only. As we agreed, in iron, I will use argon as the noble gas. What I will do with the argon, what I'm going to do is I will just write argon. I will just write argon. So this is like a summary here, telling him, please see the configuration from the beginning to argon and then continue after it. I will not write 1s2, 2s2, 2p6. I will write you argon. So you continue after argon, and I will write it in brackets like I'm doing it as in concentration. So shorthand is writing the previous noble gas in brackets, then continuing what's next. In our case, I will write the configuration of the previous one. What is the previous one for the iron? I said I will go to the left, so it is argon. So I will write argon, and then after, right? So I will write AR here, and then continue. What is after argon? I'm still here 1, 2, 3, 4th period. So I'll go to 4s. So it will be 4s2, and then I'll go to 3d. Remember that when I go here, I will have to minus 1. So I don't say 4d. I don't say 4d. I will say 3d. Always in the transition element, I will decrease a number. So if you are 5, you will say 4d. If you are 6, you will say 5. So every time I'm decreasing a number. So 3d. How many electrons in the iron? Let's have a look. This is 1, 2, 3, 4, 5, 6. So I have 3d, 6. This is not an exception, it's normal. So 4 is 2, 3d, 6, and stop. What is the meaning of shorthand? I did, instead of saying 1 is 2, 2 is 2, 2p6, 3s2, 3p6, like that, I removed all of that and said argon. So I canceled, this is a shorthand, I canceled all that and wrote argon. Then continue after the argon, as if I am continuing. Continue. I will not make shorthand again. Shorthand is on the argon and then continue after it. So let me type here, it's argon, and then this is 4s2, 4s2, and then 3d6. Okay, check the answer. Yes. So this is iron is 26. Use the largest noble gas with fewer electrons before it. Argon, it's 18 electrons, and then you have to 26 minus 18, so I have 6 more electrons. One is 4s2, and then 3d6, and it's done. The next question here, number 31. Number 32, write the shorthand electronic configuration of the following. Titanium. So titanium is the same thing. Go to the previous noble gas, but this is iron. Take care. I will tell you how to do the iron. So titanium 2 plus. Let's go to the periodic table in k-chemistry.com if you want to see the site of this periodic table. Here is the one. So now he's talking about titanium. So let's see, where is titanium? This is titanium. So what is the shorthand? Go to the noble gas. Where is the noble gas? These are the noble gases, these colors. So go to the noble gas that's before it. So I go to the left until I meet the first noble gas. It's argon. So I will write, it's not argon every time, it depends. If you are talking about palladium, so go left, 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 you will meet the krypton first. So here it is titanium, so I will write argon. This is argon. Argon is stopping at 3p6. This is 3, and this is p and 6. And then here 4s2. So I'll go for 4s2. And then scandium and titanium. So I have 2 in the D. So I have, remember we said 2, they change from 4 to 3. Not say 4D, it will be 3D, 2. But take care, something important here. I'm asking to find 2 plus. So I'm asking to find 2 plus. 2 plus means I lost 2 electrons or gained electrons, lost 2 electrons. I have to lose 2 electrons. If you lose the 2 electrons that you have in the D, you have 2 electrons already. So this means that you will cancel it. So this means that you will cancel the D. Once you cancel the D, no need to write it anymore. So the answer will be 4s2, 3d2. No, it will not 4s2 and stop. But here is the mistake. Here is the problem. The problem is that whenever you are losing electrons, you lose the electrons with highest energy. So you don't take out the electrons from the D. Always remove the electrons from the S first. Mister, but I'm going here S and then D out. Remember the rule. The S has higher energy than the D. So the 2 electrons that you are going to cancel is not the D ones, the S ones. Very important. So 4S before 3D, very, very important. So these 2 you will cancel out and make it 3D2. So it is argon 3D2. Take care. This is very important and can cause you a mark in the exam if you are not aware of this rule. Don't remove the electrons from the D first, remove from the S first. So my final configuration will be is AR3D2. You don't lose the electrons, you lose the 4s electrons first. These are the outermost electrons. Let me type it here. This is AR3D2. I have one more. I have one more here. The P3 minus, the phosphorus 3 minus. Take care, the phosphorus and 3 minus. It's not 2 plus, it's 3 minus. The electron this time is added or removed. Oh, this time the electrons are added because it's negative, not positive. So this one is correct. Let me see the phosphorus, what it will be. I still need to do the shorthand. So let me see. This is phosphorus. Where is phosphorus? Means phosphorus is here. Where is the table? noble gas. No, not the after it, not krypton, not argon. Let's go to the left. Always go to the left until you see the first noble gas. It's neon. So write the shorthand is neon, and then after neon continue. This is 1. So this is 1, 2, 3. So this is 3s2. So after neon you continue 3s2 and then 3p1, 2, 3. So 3p3. Take care, I will add 3 more electrons. So it will be 3p6. 3p6. So it will be 3p6. This is the configuration of the argon actually. So this is the configuration of argon. So I can write neon 3s2, 3p6. It's better configuration of argon because once phosphorus gains 3 electrons, it gets the electronic configuration of the next noble gas, which is argon. So I can directly write argon. This is the correct answer. It's argon only because phosphorus, once it gains electrons, it becomes argon in the electronic configuration.